first of all, happy holidays. Whatever you celebrate, whatever this year, I wish you all the best in the upcoming year of our Lord 2025. What I'll do now is continue with some data structures, and I'm gonna work. Where are you? Let me just find it. It's here. Yeah. So last time we created a linked list, and now I'm gonna create stacks and queues. Why doesn't it work? Oh, okay, I need to exit it. Let's add some code and let's start working with stacks and queues, or basically implementing them from scratch. All right, so let's start with the stack. So what's a stack? A stack is a linear data structure that follows a principle of last in, first out, which means that the last element, which is added to the stack, will be the first one to get removed. And the easiest way to remember this is to create an analogy of a stack of plates in a restaurant, for example. The last one that's clean, that gets put on the top, is the first one that gets picked when a meal is prepared. That's it. That's basically the definition of it. Now, there are some key concepts of a stack. So it uses the following basic operations: pop, which will remove the top item from the stack; push, which will add an item to the top of the stack; peek, which will return the top of the stack; and is empty, which will return true if the stack is empty. The peek one is also called sometimes top as well. So is my tablet working? Yeah. I'm just gonna create a mind map for myself so I can remember what I'm working on. So basically, so it's this one is too small of a font, maybe a stacks and queues. All right, I'm just creating a bubble, a cloud around it. Right, the first thing is that a stack, and specifically target the stack. The stack is using a last in, first out principle when handling element additions. So how and where can we find some applications of a stack? Let me just add the method as well. So we have push, we have pop, we have is empty, and we have top or peek. So we can use a stack when we, for example, want to undo some functionalities in text editor such as Word or LibreOffice. When we want to parse some syntax, or for example, in programming, we use stacks in a data structure called call stack for function calls, where we stack functions and the order in which they should be run. Where else? Depth first search in graph traversals, and so on and so on. So let's start. Let's implement this. Let's implement this. It's here. So it's a stack. I'm gonna define it. There are no items right now because it's gonna be empty when we initially. Now we have push. We have push. We have. Oh, let's start with the push. Let's start with the push, and we're gonna add elements one by one. So, if you think about it, basically the stack is just a data structure that has additional logic on top of the array. So the only thing we need to do here is when we push elements is just to select the items, and append the new item. Right. Now we can also pop this guy. So if now here we are gonna use the isEmpty method. So maybe check for isEmpty. I'm just gonna do this so I can remember. I can return self items pop. Nice. There's also the peak. Again, check for isEmpty. I just do this because I haven't yet implemented isEmpty. But it's gonna be also really simple. So peak return self items. So I'm just using the built-in array methods here. We have peak. Now isEmpty. Here we're gonna create a function that's gonna be that will be used in peak and pop. So what am I checking? I'm checking if the length of items is equal to 0. Yeah, maybe we can also create size, return items, and maybe the display as well. Print stack self items bum. All right, I think that is everything. For those of you that might feel a bit lost when looking at this snippet of code, basically Python is just using the slice notation for extracting portions of a list, and this is the form of it. Basically, here we have the start, here we have the stop, and this is the step we are using. So basically, if we start here, if we stop there, and if we use -1 as the step, basically what we do is we start slicing from the first index and at the last, and this is the step. The -1 is the step of slicing. And in this specific case, we haven't specified anything. We haven't specified any start or stop indices, which means that we are just traversing the list backwards, and this effectively will reverse the list. But why? Why do we use reverse in a stack? We use reverse because the top of the stack is usually at the end of, as stack is defined, the top of the stack is the end of the list, because, you know, last in first out principle. And when we display the stack, we need to reverse the list, so to ensure that the top element is displayed first, then after we pop him, the next element, and this makes a more intuitive view of this data structure. So, and that's it when it comes to stacks. I need to implement the isEmpty logic. Good thing I noticed this. Where's pop? It's here. So I'm replacing this with the isEmpty check. I want to check if the stack is empty. If it is, what can I do? Maybe I can erase an error. Index error. The stack is empty. I'm gonna use the same thing here, and I think this should be enough. So one more thing, push adds an item to the stack, pop removes and returns the top element of the stack, peek returns the top element without modifying the stack, isEmpty checks if the stack is empty, size returns the number of elements in the stack, and display prints the stack in a readable format. Okay, simple enough. Now let's should I maybe do an example of a stack and then start with, no, I'm gonna use the queue now. I'm gonna implement the queue now. So the difference between a stack and a queue is in the principle they are of indexing they are using. A queue implements the first in, first out ordering, and for example, it's mostly comparable to a line or a queue at, let's say, a ticket stand, and items are removed from the data structure in the same order that they are added in it. So class queue, the methods we are using for the queue are add, remove, peek, and this empty. I could also write this as well. Yeah, maybe it's not a bad idea. Maybe it's not a bad idea. All right. So we have queue, first in, first out. What methods do we have? We have add. We have, it's not called pop anymore. It's called remove. Peek. And is empty. Let's do this. Let's do this. Where's the... All right. Here's the implementation. So queue follows the first in, first out. The stack is the last in, last out. And these are basically it. These are the main key concepts of these data structures. The only difference is, if you remember, I wrote in my mind map, I wrote that we use add and remove. You can also use enqueue and dequeue, which will do the same thing. They are just different. They are differently named. And how we can implement a queue in Python, because we are doing it here, we can do the same thing. We can implement it using a list. Self. No, I've messed something up. All right. Same thing. Def enqueue. I hope this is right. I hope this is right. So, when I click Shift and Enter, it creates a new code block. I don't need this. Self items append item. Why append? Because we are adding an element to the end of the queue. We also need to dequeue it. How we can do this? The same thing. Maybe I should copy it. Maybe I should just copy it from here. If self is empty, I just need to implement the isEmpty method. Nice. The stack, the queue is empty in this scenario. Pop 0. This removes the front element of the queue. So we will raise an error in case the queue is empty. What else do we have? Peek. This is gonna return the first element without removing it. Same thing. No, I don't want a format. Actually, I should install a formatter because I don't need to do this by hand. So what am I getting here? The first element, the first one in the line. So it's gonna be just this. Def is empty, return len self items equal 0. Size is just as this, and I'm just gonna do a copy of these guys. So the size should be like this, and this is gonna be Q is going to be self items. All right. Is this working? Will this run? Let me execute everything above. Continue execution. Can I don't want. How did I add a breakpoint here? Execute everything above, and run by line. I don't want to run by line. Execute cell and below. This should work. Okay, this works. But this is really simple. Let's now do some exercises. What should we do here? Yeah, I just want to add something regarding queues because there are some performance considerations because we use a list for a queue. Because when we pop elements, when we remove elements from the front of the list, basically this operation is taking on time. Why? Because we need to shift all other elements by one because we removed the first element, right? There is I think there's a library in Python that has queue built in that provides O1 operations for appending and popping elements from both ends. But this is simple enough. In the end, we just want to use these simple classes in order to build on top of them with some good interview questions. All right. So the first question asks the following. Let me open this. So how? So it's a question regarding stacks. How would you use a single array? Now this question seems like something that you need to think about it, but it's relatively simple. Basically, to implement 3 stacks using a single array, we need to divide the array into 3 parts and manage all of the parts separately. And each stack will have its own area in the array and maintain its own top pointer. I don't want to implement this, but maybe we can go over it on a more theoretical basis. So we need to divide the array into 3 equal parts. Let me just get my tablet back on. So if the size of the array is n, so each stack will get n over 3 space, and we need to have 3 pointers to track the top elements of each stack, and these pointers are set to the start of their respective regions or positions, and we'll have push and pop, and they will be limited to the region. So if this is an array, we divide it in 3 parts. So this will be one region, this will be another, and the third one will be the last region. Again, we can use 2 types of solutions here. We can use a flexible division, or we can use fixed division. So the fixed division will waste maybe a bit of space if one stack grows larger while other remains small. And yeah, we could create a maybe more flexible approaches to allow the stacks to dynamically grow and shrink within the array. But I don't know if this is all right. Let's do the fixed division here. Let's implement this. So this is gonna be a class. Oops, we are done with this, right? Yeah, class. It's gonna be called 3 stacks. No, I again clicked shift and enter for some reason. Self and size. Let's initialize it. So Oops. So we started working on an implementation of a single array, which will hold 3 stacks. So how are we doing this? Let me just open the tablet again. So what I think we need to do here is, first we need to create an array that will have a size. So if this is an array, it needs to be multiplied by the size we are looking for. And also we need to have not only the size that we are providing in the constructor, we also need to have an internal self.size that will be part of the class itself. We need pointers that will point to the top element for each stack, and we need the starting indices. So let's do this. We have self array is gonna be what? An empty array? No, none. So nothing times the size. Nothing times the size. Now we need a size here as well. It's gonna be size. Let's create top pointers. All right. And let's create the offset for each stack. It's gonna be all right. Where did I stop? Yeah, I'm creating the offset. So the first one is at 0. The second one is at size divided by modulo 3, and the third one is 2 times the size. So 2 times size. So the size here is 9. The array will have 9 elements. Each size will be size divided by 3 is going to be 3. The offset is starting the first one at 0, the second one at 3, and the third one is at 6. So we have 3 chunks of code here. All right, so let's push it. Push stack number value So I need to push a value onto a specified stack, right? But we might have a problem in which the stack might be full. So how can I handle this? All right, so what do we have here? We have stack number. So if what are we checking here? We are checking if the slice that we want to add, if it's bigger than the size. If it is, let's just create an error. stack number is full. All right. Otherwise, we're going to do the following. Self, we are checking the slice of the stack, and we are increasing it by 1. Why? Because we are checking how many elements we have in a certain stack. So what do we have? We have index. So the index is, we have the offsets, we have the stack number. This and next, and next self array index is the value. Okay, so we increase the index, the tracker for each individual slice. Next, we get the index of it, which is gonna be the offset that we want to push our element to, our value to, plus the index at which this element finds itself inside the slice. And then we just add our element at this certain index. All right. All right, let's pop it. So stack number, we need to pop an element, but we need to check something, and we need to check if self top stack number. So if our slice has doesn't have elements, I'm just gonna add an index error. Stack number is empty now. Stack number is empty. And now we're going to do more or less the same logic, only a bit inversed to fit pop. So I'm going to create an index that I want to remove. It's going to be what? The offset at this slice plus the index of the specific slice. I'm looking for the value that's found here. So now I need to remove this value. I'm just gonna set to none because we have a fixed array, so we're gonna have 9 elements either way. Next, I'm reducing this by 1, and I'm returning the value. All right. All right. What is the next one? The next one, oops, I misclicked here. The next one will be, do I even need to implement? Maybe I should implement also the next. methods as well. So what other things we need to do? We have push and pop, we need is empty, and we need peak or top. All right. Why is there a 0 here? An unnecessary 0. So this is gonna be peak. This is gonna be peak. We need to pick the top value of the specified stack. If the stack number for this slice doesn't exist, what am I doing? I'm raising an index error. Let me just copy it from here so I don't. Why? All right, I'm gonna use the same logic here. I need to find the index, and the index will be the offset of the stack number plus all right, plus the element, the length of the slice itself. And then just doing return self array index. This should be all right. Empty, it's empty. So empty should work on individual stacks. Let me just remove this. I also need to display it. So I'm gonna print the whole array first, and next I'm gonna print all individual slices. All right, I'm also gonna print back. All right. Now this should be enough. Hopefully everything above runs. No incomplete input. Line 57. What? Can I select all of this and just return it a notch? This should work. Yes. Right. Let's test this. So stacks, 3 stacks of 9 elements. Let's display them first. We have an error here. 3 stacks, object has no attribute offsets. It's offset. Let's put S's here. Okay, now the whole array is empty because we are using fixed length. We have our 3 individual stack slices as well, and each of them is empty because, of course, we haven't added anything yet. All right, let's add some logic here. Anup, hey, thanks, man. Thanks a lot. Hope you have fun and get your dream job. Thanks. Thank you. wish to you and to everyone watching this everything great for the following holidays and in the next year, of course. So thank you so much. I also wish all the best for you as well. Where did I stop? Yeah, I stopped here. So the first stack, I'm gonna add A. Will this work? No, because the stack is not divided. Three stacks object has not. Top, stop, self, top, tops. I hope all of you guys are also having a great year. Actually, you are hoping to get a great year. The year has just started. All right. So this works. We added this element to the first slice of the stack. But how is this working? Basically here, can I put the debugger here? Yeah, I can. Nice. And why doesn't it trigger the debugger? What does it say? Click to add a breakpoint. But I added it. Can I? Stacks push 0. Run all. Clear all output. Restart. No, I don't want to. Why is my debugger not working here? Breakpoint. Where's the breakpoint? Okay. Where's the breakpoint? Why is the breakpoint not working? 3 stacks. Debug. So if I click debug here, okay, it stopped here. Nice. So what we did, self, I don't care about. I actually, here we have the array itself, which is a regular array with 9 empty elements. We have our offsets, which are calculated based on the size of the array. Here we have the size, here we have the top elements. So I'm checking now to see if my first stack is 0, if this element is greater than the size. It's not. It's not. So I go immediately to here. I'm increasing this stack index by 1, which means we have one element here. Its index is 0, and now I'm looking at the index to add. It's gonna be 0. I'm just adding it to this index, and that's it. That's it. I don't think there is anything more to add. I'm just gonna add a couple of more elements here. All right. So 1 is gonna be M. 1 is gonna be N, and 2 is gonna be T. 2 is gonna be U. 2 is gonna be V, and 2 is gonna be it's in W. I don't know English. Is not my. I think it's W. The next one here. So if I run this, 2 is full. So it stops the execution. All right. Nice. So what we have here, we have our elements that we added based on the stacks that we have. I really like this. I really like this. Nice. I can also use peek and it works. This is great. Okay, let's do another problem here. I can remove, I think, all of these lines of codes, and I need to add markdown. No. Right, so here's another example. It says, how would you design a stack which, in addition to push and pop, has a function min, which returns the minimum element? Push, pop, and min should all operate in all one time. Okay. All right, friends. So let me just open this. Let's open my good friend, the tablet. All right. So the question says, where can I write the question here? Design a stack which has push, pop, and min. So push, pop, and min. A min will return the minimum element, but all of them should operate in all one time. So I know that the first guess anyone has, even I did, is just iterate, find the smallest element, that's our guy. But push, pop, and min should all operate in all one time. So they all need to be instant. I can't iterate any structure. I can't do this. I need to keep the minimum element, the access of the minimum element stuck to constant time. Right. So what I'll do here is I'll copy the regular stack implementation that we have. Code. What? Where's the code here? Code. Ah, is this buggy? It is buggy. Okay. I'm gonna call this stack with minimum. Okay, okay. So the question is, how would we design a stack which, in addition to push and pop, has a function min, which returns the minimum element? Push, pop, and min should all operate in all one time. As I said, so we can't just iterate through the stack. We need an what do we need? I think we need an additional stack which will track the minimum element at each level of the stack, right? We need an yeah. I think I immediately thought of an auxiliary data structure that keeps this minimum value relevant and which can instantly retrieve it if we need it. So yeah, let's do this. Let's create two stacks. Self main stack. All right. And min stack. Self, I'm pushing this on the main stack, but I need to do something else here. I need to check. Okay, what am I checking here? I need to check if so. Are you fucking me? Ah, yeah. There's no exclamation point that behaves as a not in Python. I need to write not. If not, self min stack. So if you don't have a min stack, or the value that we try to add is the value, let's use a value here. So if the value I'm trying to add is less than, it's less than the top element on the minimum stack, self minimum stack pen value. All right. Hey, what's up? What's up, guys? What's up, guys? So for those of you who joined, I don't know, I'm just streaming in order to learn a bit more about stacks and queues. I already implemented them above, just the regular stack and queue, and now I'm working through some interview questions that deal with some specific use cases of them. Okay, so this one, specifically this guy that I'm working on right now, it says, how would you design a stack which, in addition to push and pop, has a function min which returns the minimum element? Now the first guess would be just to iterate to it and pick it, but we need constant time of accessing these elements. So the idea is to create a auxiliary stack that's gonna act, and it is gonna hold the element, the element to keep track of the minimum values in our stack. All right, I implemented the push, so let's do the pop. So what I did, I just copied the regular stack and I'm just building on top of it. So. How can I pop? All right, first things first, I need to check if let me also update this guy. Length self main stack is equal to 0. So this one should work immediately. Now that we updated is empty method in which we reference our main stack. So this piece of code, if the main stack is empty, we're gonna get greeted with this error message. But what? Okay. This I don't need. So I need to pop a value. So value itself main stack pop. I'm getting it from the end. I'm getting it from the end. A double enter there. Joke. If now I got a value, I popped the last element. So if value is equal to the if the value that we just popped is equal to the last item in the min stack, we also need to pop this element from the min stack as well, and then return the value. All right. Now, let's create the min method. Self. I'm just gonna return self min stack. Give me the last element here. Yeah, let's also do this quickly. If not, self. So if you don't have a min stack, I'm gonna raise an index error. We don't have anything on our stack. All right. This is simple. The size is the self. I don't need items anymore. So all of these items are gonna be self main stack. All right. So what happens here? I'm pushing the value here. I'm pushing the value onto the main stack, and I'm only pushing it to the min stack if it's less than or equal to the current minimum. What's the pop doing? It's removing the top element from the main stack, and if the top element matches the top element of the min stack, I'm also removing it from the min stack as well. This just removes the top of the min stack. So how can I do this? It's gonna be stack with min stack push 5 stack push 2 stack push 8 stack push 1 stack push 3. Let's play, run all. This is the stack. What if I stack min? What is the minimum? So it's 1. All right. So what happens now if I pop an element stack pop stack means that the minimum is still gonna be 1. Main stack. Where's the main stack? be careful with your names, friends. But if I pop it again, suddenly we have 2. So first of all, why does this work in O1 is because push and pop are both on the main stack, and these are by itself O1 operations, but the main one is always stored at the top of the main stack, so accessing it is also done in constant time. All right. So how is this working? Let's just go one more time over it. How is this working? I'm pushing 5 onto the stack. And it's here. And I'm pushing 5. So if I don't have the minimum stack, or if the value is less than the current value of the minimum stack, what I'm doing, I'm pushing the 5 onto the stack. Next thing is the 2, it's smaller than 5, so I'm pushing it onto the min stack. The next guy is 8. It's bigger, so I'm not doing anything with the 8. I'm pushing 1 to the min stack, and then I'm pushing 3 to the min stack. And now if I print, can I print the min stack? I think this is gonna show display min print min stack self min stack. I'm gonna do the same thing here, -1, and if I run all, alright. Email syntax, perhaps you forgot a comma. Yeah, I did forget a comma. Thank you, Python programming language. Stack min stack, and if I print it, so if I display min, this is how it's called. It's not min stack, display. So if I'm right, the min stack should have 1, 2, and 5 on it. 1, 2, and 5. Yes. Okay. Another relatively simple. All right. So I still have a couple of questions in regards to stacking queues. I'm gonna do them at a later time. I'll end here, and I want again to wish you all the best in the new year, and I wish for this year to be the best one in your lives yet. I need to end this now. I'm really sorry. So here's some other time. Bye bye.